So what is an agent? What is an AI agent? So this is the most hyped up word which you will hear in the year of 2025. Agent in traditional sense meant a person who acts on behalf of another person or group. For example, you have a travel agent earlier whom you used to contact, and you would say that, okay, I need to go to so and so place, please book the tickets, please book my hotel stay, and so on. Right? Or it could be an insurance agent whom you will reach out for an insurance policy. So, what is an AI agent now? So there are multiple definitions. Different companies have different definitions. For example, IBM says that agent refers to a system or program that is capable of autonomously performing tasks on behalf of a user or another system. Right? Amazon says that AI agent is a software program that can interact with its environment, collect data, and use the data to perform self-determined tasks to meet predetermined goals. Humans set goals, but an AI agent independently chooses the best action it needs to perform to achieve those goals. Right? So if you go down, Microsoft will say that agents are like layers on top of language models that observe and collect information, provide input to the model, and together generate a solution to a goal. Right? Salesforce says an artificial intelligence agent is an intelligent system that can understand and respond to customer inquiries without human intervention. Whereas on Wikipedia, intelligent agent is an agent that perceives its environment but takes actions autonomously in order to achieve goals and may improve its performance. So the whole overall idea of an agent, okay, in a software context is that it's a software program which is capable of autonomously performing tasks on behalf of an user, or it could be another system, right? So that's like a generic definition of AI agents. Okay, so AI agents are artificially intelligence agents. Okay, so now Google released this fantastic white paper which talks about agents. So let me go a little bit over here, right? I know what is agent, how does it work, and so on. Okay, so what is an agent according to Google, right? According to this white paper. So an agent in its most fundamental form, okay, or a generative AI agent, it can be defined as an application that attempts to achieve a goal by observing the world and acting upon it using the tools that it has at its disposal. Okay, agents are autonomous, they can act independently of human intervention, especially when provided with proper goals or objectives that they are meant to achieve. So if you are creating a software or a generative AI agent for travel booking, then its goal is to actually help you with the travel booking. Its goal is not to do something else which you want. Okay, for example, you cannot ask a AI agent, a travel agent, to actually talk about the various shows which are available on Netflix or Amazon, right? Its purpose is very narrow. Okay, but you can have general purpose agents also. Okay, but here it's more narrower. Okay, so what they're saying is that the notion of agents in AI is quite general and powerful, but this white paper focuses on specific type of agents that generative AI models are capable of building at the time of publication. Okay, so what are the fundamental foundational components of agents, right? And how do these components interact to drive the agent's behaviors, actions, and decision making? So if you look at the core functionality or the core components of a general agent architecture are this. Okay, so there is something called as an orchestration layer, which has a memory which could be short term or long term, which could have model based reasoning or planning. Okay, which has the various profiles, goals, and instruction for the agent. And then you have your model, which is typically your large language model, or it could be a multi-model model. Okay, and then you have various tools. So when the user has a query, right, The agent makes use of the model, it makes use of reasoning, it makes use of its memory, the instructions, and all those things to actually find a solution to the user query using the tools available at its disposal, and then gives a response back to the user. Okay, so this architecture can be called as a cognitive architecture. Okay, now what is the model over here? Model is your large language model. Okay, and they say that this large language model is also capable of following, it's a language model which is capable of following instruction based and reasoning and logic frameworks like React, chain of thought, or tree of thoughts. So these models can be general purpose, multi-model, or fine-tuned based on the needs of the specific agent architecture. Okay, so that is the model part of it. All right, now what are tools? Okay, now tools are nothing but your various forms of APIs, right? APIs to do different tasks. A tool could be an API. For example, a tool could just update customer information in a database. That could be a tool. A tool could be to fetch weather data. A tool could be to get something about flight bookings. So you can have various kinds of tools. So think of tools as your traditional software functions, right? Or traditionally you would have written a software to do a particular task, right? So that software itself is a tool now. Okay, if you expose it as an API or a function, right? That's the idea of a tool. Now these tools, with the help of these tools, agent can access and process real world information. That's the idea. So for this you require capabilities like retrieval, augment, generation, and so on. Okay, but in this paper what they say is that there are three different kinds of tools. I'll come to it. One is a data store, one is an extension, one is a function. I'll come to it in a later part. Okay, what is this orchestration layer over here? So the orchestration layer is the key, right? This orchestration layer is what achieves the task, right? So the orchestration layer, it's a cyclical process which governs how the agent takes in information, performs some internal reasoning, and uses that reasoning to inform its next action or decision. So it's a loop. This loop will continue until an agent has reached its goal or a stopping point. Now the complexity of this orchestration layer depends upon the kind of task that agent wants to perform, and it depends on the agent. Alright. So some loops can be very simple calculation with decision rules, while others can contain chained logic. It could involve additional machine learning algorithms or other probabilistic reasoning techniques. Okay. So what is the difference between an agent and a model? Okay. This is to get a clearer understanding, right? Now models are limited to external knowledge, right? Models, the knowledge is limited to what is available in their training data, right? So external knowledge is not available, but agents can access external knowledge via tools, right? So if you think of a large language model like GPT-4, it is limited to whatever it has been trained on. But then if you introduce data via RAG or something to it, then it could become an agent, right? Then typically models are, you have single inference prediction based on the user query. So unless explicitly implemented for model, there is no session management history or continuous context. Chat history is not there. Okay. Whereas for agents, you are trying to maintain the chat history, and you also have multi-turn inference prediction based on user queries and decisions made in the orchestration layer. In this context, a turn is defined an interaction between the interacting system and agent. Okay. So models don't have native tool implementation. Agents are have access to tools which are natively implemented in agent architecture. Okay. In models, you can use prompts, for making use of reasoning frameworks to form complex prompts to guide the model in prediction. No native logic layer implemented, but in case of agents, you have this native cognitive architecture that uses reasoning frames like chain of thought, React, or other pre-built agent frameworks like LangChain. That is a difference. Okay. All right. Now, what is this cognitive architecture? Okay. So, for example, if a human were to perform a task, right? Then suppose you are planning a trip. Okay, I'll not go by the example over here, but suppose you are planning a trip, right? Then you will do research, okay, on where you want to travel. Then you will find availability dates, right? When you want to travel, then you will try to find out, what is the best way of travel over there, flights, by road, or whatever. Then where do you stay over there? So there is different stages like planning, execution, and adjustment, right? Which you do. Now cognitive architecture, or your agent makes use of this cognitive architecture to reach their end goals by iteratively processing information, making informed decisions, and refining next actions based on previous output. That is the whole part of this cognitive architecture. So at the core of agent cognitive architecture, it is your orchestration layer, which is responsible for maintaining memory, state, reasoning, and planning. As a human, you kind of maintain it and then you try to do it, but over here, how is it maintained is what is your cognitive architecture. Okay, so it makes use of prompt engineering and associate frameworks to guide reasoning, planning, enabling the agent to interact more effectively with the environment and complete tasks. That is the idea. So there are various frameworks for this orchestration layer or this cognitive architecture. One of them is React, which is a prompt engineering framework that provides a thought process strategy for language models to reason and take action based on a user query with or without in context examples. Okay, that is React. Then you have chain of thought, which is like a prompt engineering framework that enables reasoning capabilities through intermediate steps. So you create a kind of chain of thought. You break a problem into smaller problems, and then you solve problems one by one, and then you go to the end solution, right? So that's kind of chain of thought. It's basically, if I want to plan an entire trip, I would break into, okay, I want to first find out where I'm traveling, then I want to find out whether I want to travel by flight or train, what is the cheapest flight, what is the cheapest train, things like that, right? Then you have tree of thoughts, which is more about prompt exploration or strategic look at tasks. So it generalizes over chain of thought prompting and allows the model to explore various thought chains that serve as intermediate steps for general problem solving with language models. So the various thoughts which are required to solve a problem can be put into a tree basically, and then you can do parallel exploration of the tree. A lot of things can be done. Okay, so these are the various kind of prompting frameworks which can be used in cognitive architectures, right? Here's a simple example. User sends a query to agent. Agent begins the React sequence. The agent provides a prompt to the model asking it to generate one of the next React steps. Okay, so and then in the action you can actually select a tool or something like that. For example, action could be flight, search, code, none, where the first three represent a known tool that the model can choose to, and the last represents no tool choice. Okay, so these are some examples which are given over here. There is this, this is how it will look like in React. Basically, I want to book a flight. The thought would be I should search for flights, obviously, right? If you are a human. So that's the same thing over here. What is the action? You have a tool for searching for flights. Then what is the input? Where I want to travel to. The flight tool returns many options. What is the thought? These options should be presented to the user in a certain way based on the filters and other things. So that is the final answer. So this is the React loop. Okay, so this is an example of the React loop in the orchestration layer. Okay, like this you have the other frameworks like chain of thought and other things. So what are tools now? As I said, language models are excel at processing information. They lack the ability to directly perceive and influence the real world. So this is where you have these tools which are coming in. Okay, think of an agent or a software which is embedded in a robot which is supposed to navigate a room, right? Now what are tools over here? The tools could be, how do you give the 3D layout of the room as an input from the camera to this software, right? How do you perceive obstacles in that image? Okay, can I use LiDAR data, okay, to identify obstacles? Now your tools could be APIs to capture this information and give it to this agent. Okay, so depending upon different tasks, your tools can change. For some tools could be like adjust smart home settings, update calendars, fetch user information from a database, send emails. you can think of tools in whatever way you want, right? Which could interact with hardware, which could be purely software, right? So there are three types of primary tools that Google models are able to interact with. Okay, that's what they put in this paper. One is extension, function, and data stores. Okay. Now, what I understand from extensions over here is that you have an agent which has to connect to Google Flights API, but it doesn't know how to connect. It cannot directly connect to this external API. So this is where you tell the agent that, okay, I have an API. This API can be used to get the latest information. So that is this extension part. Okay. So this is part of an agent configuration. It tells the agent what kind of tools it can use. Okay. But what they're saying over here is that in this case, the agent itself will make the direct API call. Okay. It gets a little bit, tricky when compared to your function calling, where they say that in the function calling, okay, so here they say that the agent can have access to flight extension, map extension, weather extension, which in turn talks about these APIs, and based on the data, it decides which tool to use, right? Now, if you look at functions, okay, so here they have some code for this as well. I'll not go into it, but functions in your software world is nothing but self-contained modules which can accomplish a specific task and can be reused as needed. It takes in certain parameters, gives a certain output. Okay, it has a specific way of how to call it. What is the expected input, output? Okay, so what they are saying is that in the world of agents also they behave in the same way. A model can take a set of known functions and decide when to use each functions and what arguments the function need based on the specifications. What they are saying is that functions differs from extensions in a few ways. That is, a model outputs a function and arguments but does not make a live API call. Okay, whereas functions are executed on client side, extension are executed on the agent side. Okay, so they have this difference between what is a function and what is an agent over here. I'll go to that part. Okay. Just give me a minute. I'll go to that part of what is a function, where is a, okay, they also have some data store, which is about how we can get access to data via RAG and other things, right? Now your data store is an abstraction over all these different data sources, which could be vectorized, which could be using embeddings and stored in an embed vector database, and the agent can access to this data. Okay. But then somewhere, and this data could be structured data, it could be unstructured data, it could be different types of data. Okay. So there are three kinds of tools is what they are saying over here. And if you look at it, the difference between extensions and function calling is, sometimes you don't want the agent to execute a function because of security or authentication or whatever restrictions. So agent should not call the API directly. Then all the agent does is that it gives an output saying that, this function needs to be called. And these are the input parameters for the function. And then on your client side, you have code which actually executes it and gives the output back to the agent. Okay. So that is your function calling. Whereas in certain cases, what they call as extensions, you can actually make the agent itself automatically call, these endpoints and get the results. Okay. So what they're saying is that useful when you are having native pre-built extensions. For example, Google talks about Vertex Search Code Interpreter, but here this is useful when you have APIs on your system and you want the agent to make use of them. You are building an agent on your infrastructure to access certain functions which you have built, right? So what they're saying is that extensions are useful for multi-hop planning and API calling. This is more about API that is not exposed to the internet or non-accessible by Google systems. You can make use of this. Okay. And data stores is your agent side execution where you want to make use of RAG, where your content could be anything, right? It could be from data in formats like PDF, Word, Doc, spreadsheet, relational databases, non-database, unstructured data, HTML, PDF, text, etc. I would go one level more and even tell that you can have a data store for your multi-model data also, right? So that's about this, right? So this is about, what is an agent, how the agent interacts with the world, right? What are tools basically, and how you can make use of this agentic framework to achieve tasks. Now you have different agentic frameworks. Microsoft has its own agents. Salesforce has agents. Google has agents. OpenAI has something called tasks now, right? LangChain has agentic framework to implement agents. Okay, so there are different things available. And then they talk over here about how you can enhance model performance with targeted learning and other things. I would not go into this over here, right? So they also talk about how you can do agents. You can quickly write code with LangChain. They have their agent framework using Google Gemini Flash. So I would suggest that please read over this white paper, and you can try out the various things over here. So this was a discussion, I would say, on what are AI agents. And if you have no idea of what are AI agents, I hope I provided some information on what are AI agents. I'll be putting all the relevant links in the description of the video. Do check it out. This is the most hyped up topic for this year. Right, we will see more and more autonomous agents coming up, more and more agentic frameworks coming up. Everything is hyped to be solved using AI agents. I don't know how far it's going to be true, but that's the kind of expectation this year companies are setting up for. I hope this video is useful to you. If you like the video, please like, share, subscribe to the channel. See you in another video.